All right, so we're going to take a look at identifying quad and linear systems or solutions. These are pretty straightforward. Remember that anytime you have a system of equations, the solutions are the intersections where the lines cross each other. So where does this quadratic cross this linear? So it crosses right here. That's a solution, and this is a solution. So there are two solutions in this case, and every time you write a solution, it has to be in x and then y. So my first solution is my x. So if you forget the x-axis is horizontal, is you come down, that's -1. And my y-axis is vertical, you go to that, that's going to be 1. That's my first one. My second solution is going to be my x value first, so I go to x right here, that's going to be 3. And my y value between -6 and -8 is -7. Okay, so remember, a solution to a system of equations is the intersection when you have an equal sign. All right, so just put that in, -1, 1. All right, it's not going to let me put it in, but I'll just get it wrong and show you. All right, so -1, 1, and 3, -7. -1, 1, 3, -7. Okay, so the intersection is the solution. We're going to take a look at substitution. Okay, so again, we've done this a lot in class, but I'm going to go ahead and do it again. We could do it by hand, but right now what we are doing is copying and pasting, right? So we're going to highlight it, Control C to copy it, and then you're going to come to your Desmos and Control V. It's going to look weird, just fix it. Control X to cut, Control V to paste. All right, and then just double check that it's the right thing. So 5x minus y equals 21, that's perfect. All right, Control C to copy, Control V to paste. And it's looking funky, I'm going to cut this part, Control X, X out of those, Control V. All right, then I'm going to make sure it's the same thing. And I don't like that this is the same color, so I'm actually just going to copy again and paste it again. So it's changed the color to blue and delete that one. All right, so x equals 2y minus 3. All right, once you're sure you have copied it correctly, so compare your two equations, make sure that it's exactly the same. The solution is always going to be the intersection. So you can literally just click on it on Desmos and it'll tell you what it is. So my solution is 5, 4. Now we can obviously do this by hand. In fact, I'm going to get it wrong so that I can show you. All right, you're substituting this part into x. So substitute this part where you see x. So you take this and you put it in here, and then you distribute and solve the equation to get y equals 4. Once you get y equals 4, you plug it back into whichever one looks easier. I'm going to plug it into here. 2 times 4 is 8, minus 3 is 5. You get x equals 5. Okay, so you can do it that way. See, you're going to get the same answer. Or by graphs. So remember, by graphs, the intersections are your solutions. All right, same thing with elimination. We can change elimination to be a graphing question. I'm going to select all of this at the same time. Control C to copy, delete what I have, Control V to paste. And then I'm going to come and take what I need. So I need here, Control X, and I'll paste it, Control V. And then here, Control X, Control V. All right, and then I'm going to get rid of this extra line. Make sure they're two different colors. If they're not two different colors, go ahead and Control C again, Control V, and then cross out the extra one. All right, then make sure, okay, always make sure it is what is in the question. -9x minus 7y equals 4, 5x plus 3y equals 4. Perfect. All right, so again, anytime you're doing solving a system of equations, the intersection is the solution. I can't see this really clearly, but if I click into one of these, what happens? I get the dot. Okay, so 5, -7 is my solution. So 5, -7. Okay, and I'm going to get this wrong again so I can show you real quick how to eliminate. And remember, you could always use your alternate method as well, right? All right, so elimination means you go ahead and you multiply. You line them up, x, y, 4, you multiply 5, and you multiply 9. So you do the x thing, right? Now, always first check to see if you need to multiply by a negative outside by seeing if these are opposite. Are these opposite? Yes. So if because they're opposite, you don't need a negative outside. If they were not opposite, you need a negative. Distribute it in. Let me see my arrows. You're going to get this line. Distribute this in. You're going to get this line right here. Then combine them. You're going to get this line. So you'll then solve for y, so divide by -8, you'll get y equals -7. And just like before, you plug in -7 into any one of these equations, whichever looks easier. So you can put it right here, -7, and then you solve for x. So you still end up getting 5, -7. All right, you can use the alternate method as well. It's just your preference. All right, solve linear systems graphically. Again, Control C. And I'm actually going to do this both ways. Control C, okay, and again to cut, Control X. Oh, this looked all kinds of weird. What was it? -1/2. Seems like it doesn't like fractions. So when you're copying, just be careful of the fractions. But anyway, it doesn't matter because you're going to look, right? And then Control C to paste, Control V, sorry, to copy, Control V to paste. All right, why does that have that? I don't know why. I'm just going to paste it again. Yeah, because I don't know. All right, so that's my equation. Solve the system of equations graphically, or actually I put in the wrong one here. Oh no, this is fine. Yeah, this is right. Okay, cool. All right, boom. So here's my solution. My solution is -4, 6. So my solution in parentheses is -4, 6. But you have to put your graphs in here. So you have to copy your graphs from here into here, or you can draw them by hand. So I'm going to draw one by hand, and then I'm going to copy another one, okay, just to show you. So remember, this is your y-intercept. So you start at -8. You start at -8, and then this says you go down 1, right 2, right? Down 1, right 2. So that would be my graph. Okay, but again, you can just copy your graph straight from Desmos. So I'm going to go ahead and show you how to do that. So my first line, -1/2, is what color? Green, right? I'm going to hide the blue one just so I don't get confused. Okay, we agreed in class how we should see these boxes. You can see them as little box. So 1, 2, 3, 4, 5. Or you can zoom in until you see 1, 2, 3. There you go. And these are the boxes. So whichever way does not matter, okay? Just whichever way you find it easier. For me, I'm going to zoom to make the little boxes. So I'm going to zoom out so I can see 5, 10, 15. Okay? Those are my little boxes. So it's each box is 1. I'll take a screenshot of this so I can show you how to copy it. All right, so obviously the first line is always easy because we always agreed we can go to the y-intercept. That's always a nice number, right? 0, -8. So I can copy that line in at 0, -8. All right, it's my second point that I need to find. So again, remember, each one of these is a box right here. So I'm looking for where this line crosses a corner. This is a corner. This is a corner, this is a corner, this is a corner. All right, so I'm going to start going across. Is this a corner? Nope. Is this a corner? Yes, it is. So that crosses a corner. I'm going to go to my x, which is 1, 2. And I'm going to go to my y, which is 5, 6, 7, 8, 9, -9. So 2, -9 is going to be where I go. 2, -9. And you see it's the same line that we had before. All right, then you're going to go to your second one, highlight your second one, hide this one. Again, your y-intercept is easy, 0, -2. So my second line is 0, -2. And then you're going to find a corner. So I'm going to show you a corner one more time. So again, it's going up by ones, right? So be careful how it's going up. So that means each of these is 1. So I'm looking for corners over here, over here, over here. So I start with this line. You can go up, down, you can go anywhere. It doesn't matter. So I'm going to go up and look at that. On the very first one, that is a corner. So that is what? 1. And this is -1. So 1, -1. 1, -1. Oops. 1, -1. 1, -1. Okay. Double check your line because that doesn't look the same. What did I just do wrong? It was at 0, -2, 0, -2, and it was 1, -1, 1, -1. Oh, I went to -1. Haha. 1, x first, negative 1. So now it looks the same. So always make sure your lines are looking the same, and then make sure that this is the same right here so that you know you did it correctly. So negative 4, negative 6 is the intersection. Negative 4, negative 6, and that's right, so I'm good. So double check your intersection to make sure you copied your graphs correctly, which for some reason I didn't. Negative 4, negative 6, that's fine. Negative 4, negative 4, negative 6. What did it say I did wrong? All right, I'm going to do the long way. So negative 8, 1 down to right, that's fine. This is going to be minus x plus x minus 2, so minus 2. And it's going to be 1, up 1, right 1. That's fine. So what's wrong? Yep. Your lines are graphed correctly, but you did not state the solution correctly. Why? Oh, I didn't put the negative 6, y'all. Oh my gosh. All right, so please be careful. All right, so click on it, look at it. So negative 4, negative 6. Negative 4, negative 6. So please make sure that you copy it down. Negative 4, negative 6. All right, so that's linear by graphs. Writing a system from context. Okay, so we practiced these extensively in class. So I'm going to go over them again. Okay, remember you can take a screenshot of it just so that you can use a highlighter, and that is control, and then it looks like this button in the middle of your Chromebook. Okay, so you can use a highlighter, because if you highlight it, it's very easy to see. Okay, so you highlight, you find my number, boom, here's my number. Oop, that's not a highlighter. There's a number. What is 250 talking about? It's a game. So 250 is a game. All right, find another number, 375. What's that? A ride, okay? All right, find another number. That's what it is. What's that? Together. So this is a total. All right, find another number. So 12, both rides and games, okay? And just like we did in class, money, 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 money. So money, money, money. That all goes together, okay? So 250. So first let me define my variables. Okay, so what are the things I'm talking about? I'm talking about a game. So let's call it G. And this is the number of games. Remember, it's the number of games. All right, then the other thing is ride. So let's call that ride. And this is the number of rides. All right, set up the money with the money. So 250. So $2.50 goes with G. Plus my rides are $3.75. R equals my other money, which is $36.25. And then when you have 4 numbers, so this is a 4-number example, you set up money, 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 or something, something, something. And then the second equation, the last number is always going to be the variables added together. So G plus R is equal to 12. Okay, and that's it. All right, so let's G equal games, number of games. R equal number of rides. And then you type in those equations. I'm not going to type them in, but you type them in.